Welcome to Angles and Acid, where we learn things maths and science, and today we're looking at fractions. This is episode 2 on fractions, and we're going to look at equivalent fractions and simplified fractions. If you haven't seen the previous video, I will leave a card for you somewhere in this corner you can click on, and you can check out the first video where we define what fractions are and some of the terms that we use to refer to the different parts of the fraction. So here I've got an example. I've got basically a pie, or let's go with a pie. It's been sliced into 3, and one of those pieces has been shaded red. So if I'm counting how many red slices there are, I can show that as a fraction, just the same as I did in the previous video. But here, I want to show you that if I have my cake or pie sliced into thirds, I can also slice it into sixths, and I can also slice that into twelfths. And as long as the number of shaded spaces is the same, then they are equivalent amounts. So this middle pie, I've got 2 red slices, and the total number of slices are 6. In my last pie over here, I've got 4 slices in red, and the rest is in twelfths. So what's going on here? Well, these are all equivalent fractions, and you can sort of see that they are related to one another. You can see that if I go from here to here and here to here, I'm basically scaling the top and bottom by the same factor. To go from 1 to 2, I'm basically doubling it. To go from 3 to 6, I'm also doubling it. So as long as I'm keeping that factor the same for the top and bottom, I will arrive at another equivalent fraction. And in fact, that's exactly what's happened in my last case here, where going from 2 to 4 is basically multiplied by 2, and to go from 6 to 12, that's also been multiplied by 2. So all of these equations are equivalent. It's moving on. So fractions are equivalent if fractions are equivalent to each other if they are a multiple of each other. So here I've got the third, the 2 sixths, the 4 twelfths, etc. If we do another example together, we've got a half. Well, remembering that I can just double it up or triple it up or quadruple it up. So that'll be the same thing as double top and bottom, so that'll be 2 fourths. I could triple it instead, so it'll be 3 on 6. I could times the fraction. I could do the numerator and denominator by 4. That gives me 4 over 8, and so on and so on. All of those are equivalent to each other, which leads us to the next thing, where if I do a maths problem and I end up with an equation, let's say I end up with a answer of 4 over 8, it's bigger than it has to be, because all of these values are equal to each other. So I could swap it out for anything else. So I could easily swap it for this one, or I could swap it for this one, or swap it for this one in my mathematical working, and I haven't changed the value of the answer. I've just changed the way it looks. And in fact, most people prefer the smallest case. We call that smallest case the simplified fraction, the most simplified fraction. And it just makes everything so much easier to work with. Especially if you've got a multi-stage problem, you don't want to have this big honking fraction, which is like 500 over 238, and you have to then divide it, or you have to multiply it. It's a big number, so it's much nicer to work with something smaller. So here I've got a basic example here. 72 over 120 is exactly the same thing as 3 over 5. In fact, 3 over 5 is the simplified form of the 72 over 120. So when you get there in your working, try and consider ways that you might be able to simplify. How do you simplify? Well, there are some strategies. The main strategy that you'll find is to look for the highest common factor that can divide both the numerator and denominator. Okay, so it's got to be the same number that can divide both top and bottom. And you want to pick the biggest one possible. So here I've got 12 over 20 in my example. The numerator, 12, can be divisible by 2. I can divide it by 3. I can divide it by 4, and 6 and 12. And for 20, the denominator, I can divide it by 2 or 4 or 5 or 10 or 20. So I'm just unpacking the list there. And here I can look for what what number is common to both the numerator and denominator, but also the biggest value I can see on my list. In this case, the number 4 is the biggest value that I have that can divide both the numerator and denominator. So basically, I could do this problem by divide this by 4 and divide this by 4, and I should get the simplified fraction. So 12 divided by 4, well, that gives me 3. 20 divided by 4, well, that gives me 5. So my simplified fraction is actually 3/5. Now, I find that sometimes I'll see a fraction where the number is really, really big, and I can't find the highest common factor quickly or easily. Maybe I'm just, brain's not firing so well on that particular day. So here's another strategy that I use sometimes when I don't know what the highest common factor is. So here, let's start with a different fraction here. So I got 48 over 32. And the basic process that I use is, can I halve it? And then can I half that? Then can I half that? Can I half that? That's basically the trick. And if it's not divisible by 2, I might check if I can divide it by an odd number. So usually I go to like, can I divide top and bottom by 3? And go from there. So here, 48 and 32, they're both even numbers. So surely I can divide that by 2. So that's basically going to be the same value as, oh, sorry, let me just fix my layer here. That'll be the same thing as 2 lots of 24 to give me 48. And the denominator, 32, is the same thing as 2 lots of, I'm thinking 16. Yes, I think that's it. And from here, we can start doing this excellent process of fractions, is that if you have a bunch of things multiplied to each other in the fraction, and the same value shows up in the numerator and the denominator, you can actually cancel them out. So once I've got to this stage, I can actually cancel out both of those 2's. And so that fraction becomes 24 over 16. Now, surely we can divide that by 2. And so I can pull out another 2. That's 2 lots of 12 is the same thing as 24. And 2 lots of 8 is the same thing as 16. Here I can cross out those 2's again, and I'm basically left with 2 over 8. And you just basically keep going. So here I could keep going, and I could get 6 over 4. I could get 3 over 2. So it's not quite as elegant as the highest common factor. It'll definitely take a lot more space in your book, but if you're stuck with a big fraction and you can't figure how to simplify it down, this is one of the methods that I use. And yeah, I hope that helps you. Before I leave you this time, I'm going to give you a challenge question. Are these 2 fractions equivalent? Now, I can give you a hint. You may need to simplify one of them so that it's easy to compare the 2 against each other. So I'll leave you with that video, and I'll catch you in the next episode. Thank you guys. Bye.